Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad, India. In this session, we are going to study inversion of 4-bar chain mechanism. So far, we covered elements of links, classification, and what are the kinematic pairs, what is rigid link, what is flexible link, and fluid link, types of kinematic pairs, types of constrained motions. Under types of kinematic pairs, there are different based on nature of constraint, nature of contact, nature of mechanical constraint, and nature of relative motion. There are various types of pairs we have studied, and also types of constrained motions like completely constrained motion, successfully constrained motion, and incomplete constrained motion. And about kinematic chain and mechanisms, machine structure, and inversion of mechanisms. We covered under inversion of mechanisms for a single slider crank chain mechanism, inversions of single slider crank chain mechanism, and inversions of double slider crank chain mechanism. In the inversions of single slide crank chain mechanism, there are 4 inversions are there. And first inversion, the application of first inversion is reciprocating engine and reciprocating compressor. And by fixing link to second inversion is obtained, and the applications of second inversions, Whitworth quick return motion mechanism, etc. So thus we have studied all 4 inversions. And in the case of double slider crank chain mechanism, inversions of double slider crank chain mechanisms also covered in the previous classes. Now today, in this class, we are going to study the inversions of double slider crank chain mechanism. And very important is that before going to cover, before all the lectures, we have covered what is degree of freedom, what is Grobler's criterion in order to calculate degrees of freedom of plane mechanisms. What is Grobler's criterion? The Grobler's criterion is F equal to 3 into L minus 1 or 3 into N minus 1 minus 2 times lower pairs and higher pairs. This is the criterion formula used for calculating the degrees of freedom of various plane mechanisms. Now in this session we are going to study again what are the inversions of double 4-bar chain linkage. So what is inversion? Inversion means the definition of inversion is different mechanisms are obtained by fixing different links of a kinematic chain is known as inversions, is known as its inversions. So let us coming to what is 4-bar chain. The 4-bar chain is very simple, simple kinematic chain, and it is a much preferred mechanical device for the mechanization and control of motion due to its simplicity and versatility. So very simple. Here the 4 bars are 4 links, or 4 kinematic links, or 4 elements are connected one to another and as a complete closed loop. Then what will happen? Based on the geometry, this 4-bar mechanism can be used for transmitting motions. Suppose if the effect of geometry makes this 4-bar chain can be used as crank rocker mechanism, or rocker mechanism, or double rocker mechanisms. So like the double crank mechanism, like the different mechanisms, it can be used for different applications based on the geometry, or based on the size of the links of a 4-bar chain. It consists of 4 rigid links which are connected in the form of a quadrilateral by 4 pin joints. So these joints comes under the category of lower pairs. Now, when one of the link is fixed, so if one of the link is fixed, then it is known as a linkage or mechanism. Now it is a 4-bar linkage or 4-bar mechanism. Now, what are the names of these links based on the rotation or based on the particular state of the links? If the link makes complete revolution, if any one of the links makes complete revolution, it is known as crank. That means crank element always makes complete revolutions, complete rotation. Now, if the link opposite to the fixed link, if the link opposite to the fixed link is called the coupler, and the fourth link is called the lever or rocker. What it does? The lever or rocker does oscillations, or it also acts as another crank if it rotates. So these are the different names are given to the links based on the rotation or based on the position, based on the function of the links. If any one link complete rotation, then it is called as crank, and the link oscillates, it is known as oscillator, and it couples the crank rotation element, oscillation element, then that link is known as coupler. And one of the link must be fixed, then only it is known as a kinematic chain or mechanism. So this is the introduction of a 4-bar chain. Very, very important. When this 4-bar chain is having a 4 turning pairs, so one of the turning pair is replaced, or one of the element, one of the link. Suppose it's link 1, and link 2, link 3, and link 4. If the link 4 is replaced by a slider, then it is known as single slider crank mechanism. Link 1 is fixed, link 2 is acting as a crank, link 3 is a connecting rod, and link 4 is a slider. So these are the 4 elements having different names based on the purposes of those links. So the purpose, this link 2 is under complete rotation, it transmits under rotation, then link 2 is called as a crank element. Whereas the link 4, what it is doing, it does the sliding motion. The purpose of link 4 is sliding. When the link 2, the crank rotates 360 degree. At that time, this 4 is called as a slider. Link 4 is called as a slider element, a slider link. To complete this linkage or mechanism is called as single slider crank chain mechanism. In the previous classes, by fixing a link 1, the first inversion is obtained. That first inversion, the application of the first inversions are reciprocating engine and reciprocating compressor. And by fixing link 2, it obtained as Whitworth quick return motion mechanism and rotary engine. And by fixing link 3, it can be obtained as crank and slotted lever mechanism. And by fixing link 4, we can see in the case of hand pump. So thus there are different mechanisms are applicable or used for these inversions are used for different applications by using single slider crank chain mechanism. Now that is the introduction. Let us discuss about furthermore about the 4-bar linkage. So as I discussed the 4-bar linkage, as I mentioned before, now here the figure 1.33, this figure indicates the length of D is equal to the sum of A plus B plus C, A plus B plus C, in which the length D, if D is more than, if D is more than, if D is more than A plus B plus C, this type of linkage cannot exist. So there are certain rules are there in order to transfer motion, if in order to require, if we want some transformation of motion, the rotary motion to be converted to reciprocatory motion, or rotary motion again converts to rotary motion, or oscillatory motion to be converted to oscillatory motion, the way we need, according to that, we have to change the lengths of the links, and also we have to fix the different links. So there should be some rules and regulations, am I right? Those rules are defined by a Grashoff. That's why Grashofs Law is used in order to transmit motion. So that means D should not be greater than the sum of the lengths of the links A plus A, B and C. Okay, that is one of the rule. Next, suppose if you see here the link, there are A, B, C, D links are there. The D is the shortest link compared to other links. And what about B? The B is the longest link. D is the shortest, B is the longest compared to A and C are intermediate links. So if we fix according to Grashofs Law, going to mention here itself, so that the Grashofs Law states, which states that a 4-bar mechanism has at least one revolving link if the sum of the lengths of largest link and shortest link D plus B is less than the sum of the remaining links C plus A. Am I right here? A plus C. Yeah. D plus B should be less than C plus A. On some of the books, they mentioned that length of the longest plus length of the shortest should be less than remaining two links P plus Q. P and Q are intermediate links. So this law is called, provided what? A 4-bar mechanism has at least one what link? Reciprocatory link? No, revolving link. Then if the sum of the lengths of largest plus shortest links is less than the sum of the remaining two links, sum of the lengths of other two links. Yes. Now that is law. That law is called Grashofs Law. Grashofs Law. Very important. Now here, very important, as I discussed it just now, a 4-bar chain. Suppose if the link 1 is the shortest link beside the shortest link are fixed. The shortest link beside is, there are two links are there. D is beside to A and D is also beside to C. If any one of the link is fixed, either A or C, suppose A is fixed, then what type of mechanism is obtained? The mechanism which obtained is called as crank rocker or crank lever or rotary oscillating converter mechanism. We can see here in the figure B, figure the D shortest link beside another link, that is C, is fixed. Then link D acts as a crank. Okay, link D acts as a crank. It complete revolution. And what does B? Then when D become completely rotating, the B can't be rotated. Why? Because beside the B it is fixed, C, and the length is longest link. So what B does? The B does only oscillating. Okay, it oscillates. So B can't be rotated because we fix the shortest link beside that. But the shortest link can be rotated, act as a crank. If it is acted crank means it rotates completely, one revolution is completely under rotation. Alright, under full revolution, can I have full revolutions? So that's why it is called as crank rocker or crank lever mechanism or rotary oscillating converter. So I have taken this animation from the website source. It has mentioned here. It has been mentioned below the link. So this has been, we can use it how the crank and rocker, that means according to beside the figures, D is the crank, this is the D. And what about B? The B is the, B is. And C, it is fixed. One of the C is fixed, either C or A fixed. And it acts as A. Alright. Thus it functions. That's why it is called crank rocker. This is one of the inversion. Next, suppose if the shortest link itself fixed, then what will happen? Yes. Then remaining links are free. Then what will happen? This is what? Or the longest link is fixed. Now we will see if the shortest link is fixed, then what will happen? And if the longest link is fixed, then what will happen? So the link opposite to the shortest link, link B, is fixed. And the shortest link B is D is made as a coupler. And the other two links beside B, A and C, become oscillators. A and C becomes oscillates. Okay. When A approaches the extreme side or A link approaches, then where it goes? So the midpoint of D, when D becomes a D dash, the center point, this is D double dash, this becomes D double dash and A. So AD double dash, similarly it oscillates. Now I am showing here in this animation, I fixed link B, I kept it down. Okay, and it becomes a D, and it is A and C. So the AC becomes the rockers. That's why it is known as double rocker mechanism or double lever mechanism or rocker mechanism or oscillating converter. These are the different names are given based on the motion of the links. Okay. Now this is a second inversion of the 4-bar chain, 4-bar crank or 4-bar chain linkage. Now let us discuss, very important, a linkage in which the sum of the lengths of the longest and the shortest link is less than the sum of the length of link other two links is known as class 1 4-bar linkage. That is class 1. That is L plus S is less than P plus Q. If L plus S are length of longest and shortest link sum is more than the P plus Q, the linkage is known as class 2 4-bar linkage. In such a linkage, fixing of any one of the links always results in rocker mechanism. Fixing of any one of the links always results in rocker mechanism. In other words, the mechanism and its inversions give the same type of motion, that is known as double rocker mechanism. So this is a Grashoffs law. According to the Grashoffs law, L plus S should be less than equal to P plus Q. That is what then only it is known as 4-bar chain or chain linkage, or having a certain motion. Having motion, then only it is called as mechanism. Now further, we are summarizing very briefly what will happen here. If what you have studied, if the shortest link is fixed, then what will happen? If the shortest link is fixed, the chain will act as a double crank mechanism. The chain will act as a double crank mechanism in which links adjacent to the fixed link will have a complete revolutions. That is what D is here. If D is fixed, then what will happen? This complete revolution, double crank mechanism. Alright? That is what, that is complete revolutions. That is called double crank mechanism. If the link opposite to the shortest link is fixed, what is the link? B is fixed. Then that is what here in this mechanism. Opposite to the shortest link B is fixed. Then it is known as double rocker mechanism. Alright? And if the link opposite to the shortest link is fixed, then the chain acts as a double rocker mechanism in which links adjacent to the fixed link will oscillate. That's what rocking, oscillating. And if the link adjacent to the shortest link is fixed, in the first case, then what is called adjacent to the shortest link is fixed. Either A or C, if it is fixed, then it is called crank rocker mechanism. As you see, that is known as crank rocker mechanism, in which the shortest link will revolve, full revolution, and the link adjacent to the fixed link will oscillate. So that's why it is called crank, rotary oscillator, rotary oscillating converter, like that 4 names were given based on the motion. Now, very important is that in some of the books mentioned different manner, but these are the important of conversions of 4-bar linkage. If the sum of the lengths of the shortest, largest and the shortest links is equal to L plus S equal to P plus Q, then what will happen? L plus S equal to P plus Q, then it will happen, it is called parallel crank. Then equal means when equalities exist. The 4 inversions in general result in mechanisms similar to those as given by Grashofs Law, except that sometimes the links may become collinear and may have to be guided in the proper direction. The purpose is served by the inertia of the links. A few special cases may arise when equalities exist. What are they? There are 2 are there. Number 1, parallel crank 4-bar linkage, and second one is deltoid linkage. What is the parallel crank 4-bar? Yeah, before we have studied inversions of 4-bar chain based on Grashofs Law. Okay. Now suppose that it is also Grashofs Law, because L plus S equal to P plus Q, then what? So there are 2 types are there. Number 1, parallel crank 4-bar linkage and deltoid linkage. This parallel crank 4-bar linkage is used in the application of tram cars or locomotive engines. This is a parallel crank 4-bar linkage. If you read description clearly, we can understand B and D both are equal. Parallel crank A and C both are parallel cranks. If A and C are equal, then automatically the joint should be equal, whatever may be. That's why here it is AC and DB. Suppose what is the shortest link? A and C both are equal. That means A plus B equal to C plus D. Okay. So this is both are equal. So such type of mechanisms are used in a locomotive engine. Let me read word by word so that we can understand better. Let us, if in a 4-bar linkage, 2 opposite links are parallel and equal in lengths. A equal to C and B equal to D. Alright. Then any one of the links can be made fixed. So D is fixed here. The two links adjacent to the fixed link will always act as two cranks. What are the cranks are here? A and C are the cranks. The four links form a parallelogram in all the positions of the cranks, provided the cranks rotate in the same sense as shown in figure. Like yes, that's what is like a parallelogram. So the use of such mechanism, as I mentioned, in the case of locomotive engine, in which the rotary motion is converted to the motion. Which motion is converted? Rotary motion only. Rotary motion is transmitted. One rotary motion of one wheel is transmitted to the rotary motion of another wheel. Okay. Previous examples, whereas in the case of single slider crankchain mechanism, in this rotary motion is converted to reciprocatory motion or translatory motion, or a translatory motion is converted to rotary motion. So, but in this case, rotary motion is converted to rotary motion to other wheel. So now for kinematic analysis, link D is treated as fixed and the relative motions of other links are found. In fact, D has a translatory motion parallel to the rails. So these are the different examples. Okay, we covered what is the 4-bar chain linkage. Very important for examination point of view. Now, in order to find out what is the degree of freedom, we can apply Grobler's criterion. And I would like to mention here how to find out the inversions of this chain by using this 4-bar chain, by using Grashofs Law. Okay, very important question, how to find out. So this is the length of link. This is the D mentioned. This is the shortest link. As we have studied theoretically, the longest link is denoted by letter B and it is denoted by letter A. Oh, shortest link is not D. In this case, shortest link is a 3 mm D and longest link is B, correct? And it is A and it can become C. Alright. Let us apply. If shortest link is, first we have to test whether it is a kinematic chain or not based on the Grashofs Law. What is the Grashofs Law? Longest link is L, shortest link is small s, this is P and it is Q. L plus L should be less than P plus Q. That should be. What is L plus S? 12 plus 3. Alright, less than 8 plus 10. Yes, it is satisfied. So it is a kinematic chain. Okay. Then we have to go for, by fixing the link, shortest link. Then what will happen? By fixing the link opposite to the shortest link, we have to define or describe the inversions of the figure shown here. Thus, solution. The length of the longest link equal to 12 mm. The length of the shortest link equal to 3 mm. And the sum of the length of other links equal to 10 plus 8, 18 mm. According to Grashofs Law, largest link plus shortest link equal to sum of P plus Q should be less than P plus Q. L plus S, longest 12, shortest 3 is other two links, 10 plus 8. Yes, it is satisfied. It comes down to the category of class 1 mechanism, and according to Grashofs Law, how many inversions are possible? 3 inversions are possible. 3 inversions are possible. Okay. Now, next step, we have to find out different inversions, right? Next step is now shortest link fixed. What is the shortest link in this figure? 3. 3 is fixed. The chain will act as what? Shortest, when the link 3 mm length is fixed, then it is beside the link, shortest link beside are 12 millimeters and 8 millimeters, will have complete revolutions. Then it is known as what? Double crank mechanism. Alright. Next, link opposite to the shortest link fixed. Now, link opposite to the shortest link. Link opposite to the shortest link is fixed. What is the link opposite to the shortest link is? Shortest link is 3 millimeter. Opposite to the shortest link is 10 millimeter is fixed. Then the chain will act as, just now we studied, please. The chain will act as double rocker mechanism. It is a double rocker mechanism. It rocks these two because the longest link, so it can't be rotated completely. So thus having particular rocker mechanism. Then that means what are the links will oscillate here? 8 millimeter and 12 millimeter links will oscillate. Now, what is the third inversion? When link 3 beside shortest link beside links are fixed. What is the shortest link beside links are? That is 3 millimeter is the shortest link. Beside links are fixed. Okay. Beside links are fixed. What is that? What is that? Either 12 millimeters should be fixed or 8 millimeters should be fixed. Then what will happen? Then 3 millimeter shortest link will act as a complete crank, complete revolution. Then 10 millimeter, then it becomes a crank rocker mechanism. It will act as a crank rocker mechanism. So the link, shortest link 3 millimeter length will revolve and the link with a 10 millimeter length will oscillate. 10 millimeter length will oscillate. Okay, there are 3 inversions we have studied here. Alright, now let me summarize completely what is the inversions of 4-bar chain. So we have studied in this session what is 4-bar chain and what is the importance of 4-bar chain and how to design the 4-bar chain, or not designing, how the motions can be transmitted based on Grashofs Law, and the importance of each link of a 4-bar chain, and if the shortest link is fixed, then what type of motions are obtained in a 4-bar chain, and links are fixed beside the shortest links are fixed, then what type of motions can be observed, and link opposite to the fixed link, opposite to the shortest link is fixed, then what type of mechanism will be obtained. Okay, so that is when shortest link beside links either A or C fixed, then it becomes crank rocker mechanism. and longest link opposite to the shortest link is fixed, then it is called a double rocker mechanism or oscillating converter. And finally, if the shortest link is fixed, then what will happen? Then it acts as a double crank mechanism. And if the sum of the L plus S equal to P plus Q, then what will happen? Equalities exist among the links. Then that inversions are called parallel crank linkage, four-bar linkage, and deltoid linkage. We have studied here parallel crank four-bar linkage. The application of parallel crank four-bar linkage is in the case of locomotive trains. And we have solved the problems. One problem model very important, that is finding out the inversions of the chain given in figure based on with the different length values of the different various links. So thus we covered completely the four-bar chain linkage inversions and its importance. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.